Hello ladies and gentlemen, and welcome to this geometry screencast lesson on the equation of the tangent line. Let's just remember the tangent line is a line that touches the circle in exactly one point. Okay, so I have this circle here. You see it graphed. So first of all, let's write the equation of this circle. The center is at the origin, so we know it's going to start x squared plus y squared. And if we count the boxes from the center to the right, the center up, center left, center down, it's 5. So the radius is 5. So the equation of this line is x squared, of the circle, is x squared plus y squared equals 25. If you look at this point B here, the point B is at the location of 4, 3. First we need to prove that that point is in fact on the circumference of the circle. So if you recall, we're going to take the x value of 4, put it in the equation, y value of 3, put it in the equation, and if that point is on the circumference of the circle, those coordinates will solve the equation. So 4 squared plus 3 squared equals 25, 16 plus 9 equals 25, and that's a true statement. So now we know that that point is on the circumference of the circle. Okay. Also recall that a radius and a tangent are perpendicular at that point of where that tangent line touches the circle. We call that the point of tangency. Okay. So, in order to write the equation of the tangent, we have to find the slope of that radius. So, what's the slope of AB? If we count boxes, it's 3 up and 4 to the right. So, slope is 3/4. Right? If I use the slope formula, 3 minus 0 over 4 minus 0, because the coordinates here are 4, 3, coordinates there are 0, 0. So whether I count boxes or I use the slope formula, my slope is 3/4. Okay. So we want to write the equation of line M, which is that line right there. And we know that it's got to go through point 4, 3. So count boxes on this line here. Okay. Down 4 over 3, down 4 over 3. Okay. So the slope of that tangent line is negative 4/3. So what do we know about those two slopes? Those two slopes are negative reciprocals, 3/4 and negative 4/3. If they are negative reciprocals, in fact, then the radius and the tangent are perpendicular at that point where the radius and the tangent meet on the circumference of the circle. So that's how you write the equation of a tangent line. So let's take a look at a different example. This one now has no graph paper. So we have this equation of the circle. X plus 4 squared, y minus 2 squared equals 136. So write the equation of the line tangent to the circle at that point of 2, 12. So on this one, we're going to presume that the point 2, 12 is on the line. In fact, it is. We could prove that. So if we look at this, the center of the circle is at negative 4, 2. So then the slope of the line connecting that point and the center will be 5/3. 12 minus 2 over 2 minus negative 4. All right, 12 minus 2 over 2 minus negative 4 is 6 over 10, reduces to 5/3. So then the slope of the tangent line has to be a negative 3/5, the negative reciprocal. And we know that the tangent line has to go through the point 2, 12. And we're going to use the point slope form for the equation of a line. So it's y minus 12 is equal to negative 3/5 x minus 2. There's no need to put it in slope-intercept form. This is perfectly acceptable, and we should just leave it that way. So if you need to go back and watch any part of this, if you need to rewind it and hear it again, that's fine. Make sure you've taken good notes. I'll see everyone in class, and thank you for tuning into this geometry lesson on the equation of a tangent line. And this lesson was brought to you directly from my dining room table.